Welcome to DeFiChain Demystified, where we dive deeper in some special topics of DeFiChain. The goal is to bring answers to some tricky questions and bust some myths. We are
Kügi,
and Mark, and today's topic is
why is DeFi MetaChain so cool?
why is DeFiChain so cool? Welcome back, Kügi. How are you?
I'm fine. I'm in different surroundings, different stuff, but
Different
everything's
location.
good.
I can see this. You are actually on vacation, but you're still available to record a fantastic new video. Kügi, last week we did a really good job to scare people, and we said everybody will go out on the open sea and die because it's gonna be so dangerous out there exploring the world. I think
You said that.
I said that. So I feel really bad that I scared maybe some people. Today is the part where we wanna talk a little bit more. Why is DMC so cool, like we said, and what's the great stuff, and why are we actually doing what we're doing that people don't think we're completely crazy to risk too much for the chain or for the users of the chain. Is that correct, Kügi? Only good news today.
Yes, that's the
Fantastic.
plan. Today we survive.
Today we're gonna survive. So let me change the volume a little bit. Cool. Hey, Kügi, I would say you brought us for sure some awesome graphics and maybe also some Kügi style animations.
It's graphics. Yeah,
It's graphics. Do you want to say something before I jump on the next screen, or should we just dive into your graphics?
I think one important thing is last time we talked about the difference between native DeFi and the DMC and the MetaChain stuff. And there we also had this what are ERC20 tokens really and stuff like that. And I think it's important for people to understand that. So if you didn't watch the previous Demystified, pause now and watch the other one. We are waiting, and then come back and because today we will base on that and go more into the what can we do with that stuff. That's the difference.
That makes complete sense. Yeah, very well. We're gonna link that up here somewhere on the screen or in the show notes. If you missed it, check it out. It's really good. It's always good to start from the very beginning. Otherwise, you might have some big question marks in your eyes or your brain. Okay, Kügi. With that said, let's jump right into your presentation animation graphics. Cool.
So to everyone who already watched Demystified, they know this overview where we say, okay, we have the DeFi chain, and now we have currently the UTXO and the native DeFi levels. Not saying layers because layer 2 is something different. And we have the DMC, the MetaChain part that's coming up now. And so all three of them basically coexist within the same chain, and we have that. And as we said last time, we have the DFI as the native UTXO token, the token level on the native DeFi, and it will be the native coin on the MetaChain. And they all share the same supply, so you have to transfer them if you want to do something with them up here. Also the question or the topic with the increased demand for the MetaChain. And now, just as a quick recap, what we can do on native DeFi and how native DeFi interaction works right now. Everybody should know what's happening on native DeFi. We have the native DEX, we have the future swaps, we have the oracles, we have vaults, and we have our DATs, our tokens. I just have put some references here, so not all of them. Where we say we have ETH, we have Bitcoin, we have USDT, we have the USDC and stablecoins and stuff, and we have our D tokens, the DUSD, and the other D tokens like Tesla and SPY and stuff like that. And on the native DeFi, we can interact with those functionalities that are done in the chain, so directly in the core functionality of the chain. We have encoded how a DEX works, how vaults work, what's the tokenomics of the future swaps, and so on. and what a token is. As we said last time, native DeFi, the native DeFi level knows what a token is, knows what a DEX is, knows what a vault is, and so on. So this is all in here, and no one outside needs to do anything, and it's a clear definition of what's happening. That has the downside that if we want to add something, if one user or some service or something wants to add, for example, options or anything, any logic, they need to do it outside. Either they do it outside, or there's a DFIP and the core developers need to have the resources to put it in, and it needs to fit all the stuff and be there, and is then on the chain for eternity, and that's the functionality that we have. So it's kind of hard to get additional stuff in there. And if you want to do something, if you want to have a bot that automates stuff, if you want a trading bot or anything, like Voltmaxi or anything that interacts with the vaults or does auctions or stuff like that, you need that outside. And that's my little bot. And you have the logic that interacts with that defines when to trade, when to do any action outside. So this little stuff here symbolizes a logic. So you have the bot and the logic outside any service. If others want to use your service, they need to interact outside of the chain with that. Mm-hmm. And also the bot or any service that does that interacts with your address, and therefore needs the keys for this address to do anything. So they need full access to your address, to the funds, so that that service, that bot, that automation can do a swap or interact with vaults or anything. Mm-hmm. So that's one thing to understand. On the native side knows everything, what is a DEX and stuff like that, but is limited to that functionality that we have in there, and everything else needs to happen outside. And now, in contrast to that, if we look at the MetaChain, we have, I would say, 3 parts. It's, as we said in the last time, basically for the chain itself, it's all just addresses that could have code. But when you think about it, I would split it into 3 parts of the MetaChain that you have for any EVM, basically. You have your addresses. With addresses, you have the balance in your native coin. So in DeFi, where you can send DeFi back and forth or interact with other addresses. Then you have your dApps, your decentralized apps. And I don't say smart contracts here, because usually a dApp has multiple smart contracts in the back that interact with each other. Just those are no endorsements or something. It's just for examples and references. I put 3 dApps up here. It's Vanilla Swap, which is a DEX. The Jellyverse, which will have DEXs and staking and whatever stuff. And the DeFi Bets, which is a small dApp where you can place bets on stuff. And which is also, and all of them have internally multiple smart contracts that interact with each other. Mm-hmm. And the thing is, as soon as you have something up here in the smart contract dApp level or area, they can interact with each other. I think they don't. DeFi Bets doesn't interact with the Vanilla Swap, with the DEX, but they could. They could say they do, for whatever reason, the result of the bet is automatically swapped via the DEX or via this DEX, do some other stuff. So they can interact with that logic. And also, if, again, the logic symbol, if I deploy my own smart contract, I can tell the smart contract to say, okay, this is the address of the DEX. There are those pools. And when I deploy it, and then the smart contract is able to interact with the DEX and swap stuff. Or the smart contract is able to interact with the DeFi Bets and place bets. For example, I could write a bot or a smart contract, which is a betting bot that says, I want to bet on the Bitcoin price whenever that and that conditions are met, and then I want to place a bet. So I could put and code this whole logic in here, and then I just need a trigger that starts the logic, because that's the only thing that the chain can do, and that's the automatically trigger something. It's all transaction based. So everything that happens in here needs some transaction that triggers it. Within this transaction, everything else can happen then. So if I, as a user, send a transaction from my address, so via MetaMask or something, to the smart contract and tell a call in the smart contract the function place bets or check and place bets, then within this transaction, the smart contract evaluates all the conditions, checks all the stuff, asks DeFi bets for the current liquidity or whatever they provide. Maybe ask another smart contract that's the oracles for the current live prices of Bitcoin, because we will have that as oracles and later on directly in the chain to have the prices and everything, and then decide within the same transaction. Then decide, calculate that, and then decide, okay, I will place a bet, and this is a sub-transaction within the same transaction, sending to DeFi bets, please place this bet from the smart contract. So that's also the thing. This smart contract could hold the funds. I could send a lot of funds to this smart contract, and sending, as we had it in the last video, if you send something with as an ERC20 token, it's not sent, but it's the smart contract of the token is updated. But for safety, so just call it send tokens there. So this has the funds and everything, and can then place a bet. And if the bet goes through and we win, DeFi Bet gives this smart contract address, because for this DApp, it's just another address with a code behind it. As we said last time, it's all just addresses which can have code behind it or not. So for them, it doesn't matter if this is a smart contract that called it or if this is an address that called it and did this transaction. So within this one transaction...
Short question, Kügi.
Yes.
Because you said many activities can happen within one transaction or within one block, or is there limitation in some way? Because you say, for example, check the oracle, then if a condition is met, place a bet, do this, do that. Can there be 100 things be executed at the same time? I mean, it's not in the same time, but within, I think the block, is it within the time span of a block, or how is the limitation there?
It's within the same time. That's a philosophical question, because it's within one block then. And as soon as the block gets broadcasted, that's when it happens, basically. Internally, it's done step by step.
Okay.
But the question is, when did it happen? Because when the miner calculated it, or when the block gets broadcasted, or whatever. So within the time is a question. But the thing is, that's why we have this gas fee. In the native part, you have the size of the transaction. In the DMC, or in any EVM, a transaction has computational complexity, basically, where you execute all the stuff, all the calculations and everything. And different calculations need different amount of gas. So gas is basically the reference for how many computational complexity do you have to do, how many logics, how many calculations, conditions, whatever. And there's a gas limit on the block. So on the one hand, it's the more you put in there, the more gas you have to pay. And there is a limit of, I think, 30 million gas per block. So you can't spend more than that in the whole block. I think that's also a bit of a limit, that the miners don't have to go totally crazy on each block. So that's a EVM block is full about the gas limit. So how much gas you can get in there.
How do I know that I pay enough gas that everything can be executed?
There is a gas estimation.
Okay.
So you can estimate from the chain the gas that you need for this transaction. When you say, I want to do this transaction, then you get a gas estimation. And yeah, sometimes it can be off. So if you want to be on the safe side, you increase the gas limit, because when you do a transaction, you usually give it a gas limit, where you say, I don't want to spend more than this in gas for this transaction. And that's how much I pay per gas. That's the transaction price then, basically. The gas actually used multiplied by the gas price that you say you pay. And the more gas price you pay, the higher you get in the priority. And that's also the base gas fee is burned. So the base gas that you pay is burned, and the other part is paid to the miner. So that's, with this estimation, you get what you likely needed gas, and then you set the gas limit. And with all the tools, it's usually done automatically. So the transaction gets into MetaMask. MetaMask asks the chain, what's the gas estimation, puts that estimation in, and you just click send, but you can change it if you want.
Good, thank you.
So that's regarding the limit.
Mm-hmm.
And yeah, that's also the thing. It executes all the stuff, and you, as the sender of the transaction, need to pay for all the stuff that's happening within the transaction, because that's all your transaction, your gas. So the smart contract itself doesn't pay the gas fee, because he's doing it within the sub-transaction of your transaction. So you pay the gas fee, but he does all the logic, and he can do stuff with the funds from his address. So the smart contract is the only one who can do stuff with the funds, and that's the important part. Because if I now say, okay, I can do this, and I can call this with a transaction from my side. So I could go every day on a Web3 site and say, okay, interact with the smart contract, check the bets and everything, and I do that manually. Or I add a bot again, and here we now see the big difference. We have the bot, but the bot has no logic.
Mm-hmm.
The bot on the MetaChain, I mean, there could be services outside that also have logic, but now with MetaChain, we can put the logic inside the MetaChain on the chain. It's already in there. It's encapsulated into the smart contract, which also means that if the bot interacts with that, the bot just says, triggers this function and says, check and place bets. And this function, check and place bets, does only what the original logic told it to. It checks the stuff, checks the oracles, checks the stuff, and then places a bet or not. So there is no way that this bot can get the funds from the smart contract, because there might be a function to withdraw funds from the smart contract, but this function can only be called by the owner of the smart contract.
Mm-hmm.
But this check and place bets can be called by any other address. So it's a public address or public function that anyone can call, because whoever calls it, this function internally makes sure that if there's already a bet, it doesn't place another one. So it must be safe to be called multiple times. But if you have that, anyone can call that. So this bot, the only funds that he needs is a few DFI for the gas price. So 10 DFI, I don't know, to be able to pay the gas for the transaction. But that's it. So if anyone hacks my server or gets access to this bot, they can't steal my funds or anything, because this is just some random address with a few gas price DFI and calls this smart contracts. And the address that's the owner of the smart contract is my hardware wallet, whatever, safe, multi-sig, whatever I want, but doesn't need to be on the server or anything. So no one can steal the funds, and they can only interact with the smart contract the way I designed the smart contract and I encoded the smart contract.
Mm-hmm.
Because here, if someone gets access to the bot, they have access to my full address and can steal the funds, do whatever they want. Here, the logic is already on the chain and no one else, so it can only execute what I told it beforehand. And one important thing is, because I had the question when I did the video in German, it can be seen as a predefined transactions, but it's far more than that. So it's the smart contract really executes logic, and based on the logic, based on the calculations and the conditions, the smart contract decides what it wants to do.
Okay,
And
so
then
that
does
means
that.
if the contract has programmed in the code go from A to B to C, then you cannot go into the smart contract and say do it the other way around. So it's a predefined way how the smart contract has to act. So that's a kind of a layer of safety that you cannot just mess up everything when you get access to the smart contract, right?
Exactly, because and when you get access, everyone has access to the smart contract, because it's on a chain and everyone can call that function. And therefore, that's why you have in there that the smart contract knows who called it. So you can code in the smart contract, if this function is called and it's not called from this specific address that created me, so my own address, then the transaction fails immediately. Because only the owner can call this. That's stuff like that.
Okay, because
So you
this was my
can.
next question. Is this the way how you protect the smart contract actually against bad actors, that you say, first of all, you listen only to that address. If it comes from somewhere else, shut down or don't execute or whatever.
It's just a transaction phase. So if someone tries to execute a transaction, that's guarded with only that address can do that, it fails. For example, also maybe one example, if we would, or if someone now creates a D-token system, let's say Jellyverse creates, I don't know anything about it, but let's say Jellyverse creates a D-token system up here. Then any user can create a vault here and interact with this vault, take loans, and so on. If we say it's a D-token system with vaults and everything as we know it. And then this stuff would have the stuff in there saying, okay, if you send me a withdraw from vault with this vault ID and that stuff, they check, okay, in my internal data, this vault belongs to this address. Are you that address? Yes, then you can withdraw. If not, the transaction fails. Stuff like this. Or if you want to take a loan, you're only allowed to take a loan from that vault if you are the owner of that vault, and stuff like that. So that's all the logic that's in there. That's the logic that's currently in the native DeFi side in the core level, where only this address can take a loan from this vault, only the owner can withdraw stuff, but anyone can pay back a loan, anyone can deposit to a vault, for example, and you can do the same stuff on the MetaChain, where the smart contract has these rules where it says, if you send me trigger the transaction from this address, then you can do that and that and that, but not that, for example. So that's all part of the smart contract. You can write it once, put it on the chain, and then when you trigger it, there is no risk of anything. It's just the other way around, of course, too. If the smart contract has an error and there is the safeguard is wrong and there's some condition written wrongly so that anyone can access it, then anyone can access it. So that's this where the hacks usually happen. When you have an error in the code, in the smart contract, and it's not guarded correctly, and someone can call a function with a special setup where this and this and this token, and then they can withdraw funds that they are not allowed to withdraw and stuff like that.
Okay, and smart contracts, when they are deployed, are in some way transparent, right? So everybody can read them, everybody can check them, or are they kind of
they are
obscured or
compiled.
hidden?
So it's hard to read them if they're not verified. Good smart contracts are verified, so they are open source, and the deploy of the smart contract verifies on chain that this code that I did here is exactly what I deployed, and then you can check that and you see the code behind it, and you can verify it and check it. So that depends a bit on the one who is deploying the smart contract, but in my opinion, every smart contract should be verified and open source, that you see what's happening there, because otherwise it's like an other service, a central service somewhere, where you have to trust them that they do what they said they do. And with the smart contract on chain, you really know what's happening there if it's a verified open source contract.
Okay, good.
Yes, and one more thing regarding that. So that's a bit about the optimization, why it's so good that you can put the logic on there. The other thing is, previously we had one DEX that worked like the DEX is defined. We have one vault system that works as the vault system is defined right now. Up here, anyone can write the DEX. Anyone can write the DEX and put it up. Like Vanilla does it, which is a Uniswap fork, I think. Jellyverse will have this Jelly swap and stuff like that. Anyone can do that and define the DEX a bit differently, maybe. Different commission rates or how the calculation of the price is defined. For example, I know Jellyverse will have not only pools with 2 tokens, but multiple tokens, that you have up to 8 tokens within one pool, which has a completely different dynamic if you do liquidity mining in there and stuff like that. And anyone can write that and therefore provide value and new functionality to the chain. And that's, in my opinion, one of the great features and improvements with MetaChain. Previously, if we wanted to say we want now 3 pools available, so pools with 3 tokens available on our DEX, it would need a DFIP. We would need to have resources from the core developers. There are not limitless resources from the core developers. So that would be big trouble. And the whole community needs to decide how should that work? How do we want that to happen? Up here, if Jellyverse says, okay, we think that's a good idea, we have the resources to do that, they do it. if someone else says, I think sweep pools should behave a bit different, they can also do that and say, okay, we put another DEX up here, and then we have multiple DEXs up here, and the users can decide what's the best way to do it. And we have this added functionality and added possibilities. So previously, it was always, if you want to add functionality and if you want to add value to the DeFiChain ecosystem, you could talk about it, you can make videos, you can make bots outside that help people to do stuff. And you can do a lot of stuff, but you cannot add value directly to the functionality of the chain. And only the core developers, I mean, you can write it and make a pull request and hope that they get the time to check it and everything. But it's really hard to get the value directly on the native DeFi layer. Here, anyone can either code it themselves or find someone to code it for them, because there's a lot of EVM coders out there, and put it up here and add the value to the chain. And because then you have the functionality up here, users can use that, and then the more users use it, the better it is for the chain. DFI gets used more demand, and the whole functionality.
So that means actually, when we said what's so cool, another cool thing is just that the growth for the chain and projects on the chain is now unlimited. So everybody can build. Nobody has to ask the core developers, can you please implement that? Can we please change that? What is everybody thinking? If you have a great idea and you have the skills to deploy a logic, a smart contract, whatever, then you can just come in and build.
Exactly.
There might be some crap that's going to be built. There might be some awesome things that's going to be built, right?
Don't let people die in the ocean again.
No, I just mean, right? It's like, at the end of the day, a lot of projects going to come, and you then just have to decide for yourself, what do you like, what is good. So there's no official certification. That's what I wanted to say. Because when the core development team decided to build it, it was kind of, okay, we all approved, that's great. Community, consensus, everybody said, let's do it. Now, actually, everybody can do whatever they want. And some things going to be better, some things going to be worse. But it helps growth dramatically, right? Because not this overall approval is needed now.
That's again the warning. Be careful.
No. We talk about the good stuff today. It's cool.
But here that's also why is so hard to get it in here, because here it really needs the approval of the whole community. Here it just needs someone to do it.
It reminds me. Sorry, Kügi. It reminds me a little bit of Apple and Google. So to get something into the Apple Store, it's always much harder because there's so much more checking and stuff going on, and people complain. It's a pain in the butt to launch an application there. It slows things down. But they check, right? In the Play Store, things are faster, more open, but also with the slight risk that everything is not checked. So a little bit more responsibility for the users, but it grows the ecosystem so much faster, maybe, no?
Great. Now you have the Apple fanboys as haters in the comments. I like that.
Why? I love Apple. I'm an Apple fan. Why?
But yeah, I mean, it's even more strict in our case here.
Yeah.
But that's the rough idea exactly, where we say, okay, here we have far more space for growth and
freedom,
because
flexibility,
it's kind of the Wild West, because anybody can do that, and then the users decide what is used and how do you want to use it, with all the disclaimers about
pros
risk
and
and
cons.
everything.
Yeah, exactly.
But that's the cool stuff, that you can build stuff now. And there's the famous one last thing, which I think is one of the main cool things, or that cool thing, because with all that we say we can build whatever we want within these ERC20 tokens that we have here, where we have the tokens, we now also with the mainnet launch, we have all our DATs, all our tokens, the native tokens, also available up here. We call that DST20s, which is basically ERC20 tokens that go up here, and they are transferable. So on the one hand, you can't create them up here out of thin air. They need to be transferred up from the native DeFi layer, same as the DeFi token needs to be transferred. They need to be transferred. So any demand for DST20s up here creates additional demand down here, basically, because they get transferred up. But now the thing is, on other EVMs, if you launch the EVM, there is no Bitcoin or Ethereum or USDD or anything in the DMC world, because you need someone to wrap it and do that stuff. For MetaChain, we have right from the start a web token. It's our web token. It's the token wrapped by Cake, basically, which is representing already Bitcoin. So right from the start, someone can make pools on VanillaSwap with those tokens. They can build stuff on those tokens, whatever they want, whatever logic we talked before, that you can do whatever you want. You can do that on top of existing crypto tokens from the other chains. So you can do, I don't know, pools between those tokens. You can do, now we are on the real DeFi, as I like to call it, because we not only have the Bitcoin, Ethereum and stuff, we also have the D tokens, DUSD and everything. And because they are transferable, they are linked to those prices here. So because of future swap down here, we have Tesla to DUSD within the range and SPY within the range of the Oracle. And so they also are within that range up here, basically, because you can always transfer them back down and swap it on the DEX here. So now you can use them and build DeFi and real DeFi, not yield farming stuff, but I don't know, decentralized portfolio managers. Automated with bots, you can write a smart contract that balances your portfolio, and that exactly like you want it to. You define in the beginning of the smart contract, I want 10% DUSD, 20% SPY, 10% Bitcoin, and so on. That's my portfolio that I want to have. The smart contract owns the funds of your portfolio. You can send additional funds to the smart contract, and then the smart contract automatically, with the sending, distributes it over your portfolio to always be balanced. And you have a function that called rebalance the portfolio. And then it checks if it's off balance, it automatically swaps it on the DEX, and you have your balanced portfolio. So you have your decentralized portfolio exactly the way you want it. You can build centralized portfolios where you say you are now a fund manager. You provide a DApp where you say, I'm the fund manager. I define how the portfolio changes. Anyone can send me funds. They get tokens in my fund token in return, and they can always redeem for this fund token the part of the portfolio that they own, basically. And that's in the smart contract, so anybody can do that, and anybody can verify that that's the way it happens. Me as a fund manager, I cannot withdraw funds. I can just define the portfolio and restructure the portfolio. And then you have a decentralized, traditional fund manager, basically, in the MetaChain, based on our D tokens, because you have these D tokens there that are in the price bound to the range based on the native layer. You can build options on the D tokens, option trading, futures trading, whatever. All this finance stuff, where we say a bit of the traditional finance part, where we previously fund managers and stuff like that, we had only in the traditional finance part. Now we can build it here directly on our D tokens, decentralized, sensorless. Yeah, the whole thing that we have, we can build that and basically get the whole world of traditional financial services in here. I mean, it's always a bit, if you are the fund manager, it's likely that you are counted as financial services and everything. So be careful if you want to do that. But just the possibilities that you can do here on top of that is much more than you can do on any other chain, because we have these native DSD20s that are in the price range and everything. And right from the start, we have the Bitcoin, Ethereum, I think Doge, and with the special DFIP that I think it was started today, about more coins, where we maybe get Solana, Matic, and DOT on here too.
Right.
And as soon as we have it here, we already have it here. So that's all that stuff that's right from the start. Why I think it might not take that much time for MetaChain to really get a lot of project and a lot of traction, because right from the start we have the coins. Right from the start we have a huge potential of possibilities and options that we can do there and what we can interact with. with the DeFi layer and with the DeFi
Yeah, and
tokens.
especially
the
we have
real-
these decentralized stocks, right? I mean, our D token, I mean, no other chain has that. So if somebody really wants to build something with decentralized tokens, then that's the place to go.
Yeah, and that's also the thing, because they are from down here. So there is this centralized, or it's centralized is the wrong word, but it's based on the native side. So they are those tokens that are from the chain. Anyone can build a D token system up here, and I hope others will build D token systems up there, vault systems up here with different functionalities, and they can then combine that with the native tokens to say, okay, we have a price binding, and therefore their tokens don't need a future swap because they are anyway connected to our D tokens, for example. Could be, but they have the vaults have different functionalities, so we have it up there too. But it's all connected or can be connected to our native D tokens, and with that you can build huge stuff. And anything that you build up here, as we said, it's this Wild West where there is no endorsement from anyone to say this is the best DEX on MetaChain, this is the best D token, this is the best bets on MetaChain, this is the best whatever options. Hopefully there will be multiple options protocols, option dApps that do option trading on the tokens, or futures trading or stuff like that, where we say, okay, different versions, different functionalities from different project teams, which all do stuff, provide different ways of value, because they have different functionalities, and therefore increase the whole ecosystem based on this stuff, on this native DeFi that we already have.
Yeah. So looking at all your squares that you've got up there, it reminds me a little bit of a big blocks with Lego building blocks, and you can. I really love Lego. So you can use all these things that are there already and build something fantastic new out of all these things. And the more people build, the more options they're gonna be. Pick and choose, build your own stuff, be creative. I think now we just need a lot more creative minds who really say, hey, there's so much here, and start building.
I think we have a lot of creative minds, and now everybody can. I think that's the one sentence answer to why is MetaChain so cool. Now everybody can build with our Lego.
Yeah, right.
Everybody can. So previously we had the core developers building Lego, and everybody was watching outside and playing with the stuff.
Yeah, that's good.
Basically,
that's a good
and
comparison.
now we opened the playground. We added huge amount of blocks there, and everybody can jump in and say, okay, I build a castle here, I build a pirate ship here, and I have a better pirate ship.
I want a plane. I want a plane.
Yeah, exactly. And someone built some Lego
absolutely. Very nice comparison. Yeah, that's how it is. So everybody's welcome to come and play and build and grow the ecosystem. Nice. Cool. Yeah, fantastic. Very nice explanation, Kügi. Thanks a lot. So after we sent everybody on the ocean in the unknown with the risk to lose their life in the last episode, now I think it was a little bit more positive tone here. So come and play Lego with us. It's all there. I like that.
If you survived the ocean last time, now you can
now
play
we are
Lego.
allowed to play Lego with us. Kügi, thank you so much. That was a good one. I like that. That was really cool, like we wrote. Enjoy your vacation. And when you come back, then we're gonna see what we're gonna demystify next and what secret we're gonna unveil here on DeFi and DeFi MetaChain.
Let's do this.
Thanks a lot. Guys, thanks for watching. Thanks for bearing with us for about half an hour. Hey, if you have ideas, what do you want to hear? What myth we should bust? Yes. Then leave it in the comments or send us a message. We're also very happy about a like. That motivates us and it helps the project at the end. Thanks for watching and see you the next time when we say again, DeFiChain Demystified. Have a good day. Bye-bye.